Howdy y'all. Let's take a look at some net force calculations here. So here's an example problem. When standing on an elevator about to go to the top floor of the IDS building, Eric accelerates upward at a rate of 2.5 meters per second each second. Those are the units of acceleration, remember. So here's Eric. Eric has a mass of 74 kilograms, so I'll write that down. We have to draw a quantitative force diagram on Eric. All right, and when we're starting a quantitative force diagram, we just start with our particle there. Eric is our particle, and we can simulate Eric as a dot. Okay, all right, and I know that Eric is accelerating upward, and I see if I go around Eric here, I see that he is touching the floor. The floor is pushing him upward, so there's a force pushing upward. There are no other forces touching Eric, but there is another force pointing downward on Eric. That'll be the force of gravity. And if the floor is pushing him upward, that is called a normal force. Okay? You may notice that I drew the normal force arrow to be a little bit longer than the force of gravity arrow. That's because I know that Eric is accelerating upward. So the normal force has to be larger than the force of gravity. I do not, however, know what the size of that normal force is. Okay, so what I can do here, let's just move this off to the side so that we have a little bit of extra room here. Okay, we have to write a net force equation from this. We have to quantify this problem. In order to do that, we have to write a net force equation. Okay, so what I'm going to do here is I'm going to write force net is equal to force normal minus force of gravity. We'll say that upward direction is positive, so the normal force is positive. Gravity would be negative. All right, we can find the net force. We can also find the force of gravity. Okay, force of gravity is just equal to mass times 9.8 meters per second squared, mass times the acceleration due to gravity, which is equal to 74, I'll erase that. I better erase that, huh? There we go. 74 kilograms times 9.8 meters per second squared. And when you do that calculation, why don't you grab a calculator, do it yourself while I do the same. You get 725.2 newtons. There's our force of gravity. Okay. We can find the net force by doing mass times acceleration, the acceleration of the object. So again, it'll be 74 kilograms times the acceleration, which is 2.55 meters per second squared, meters per second each second. Okay, so do 74 times 2.5, and we get 185 newtons. Now the key is we need to find what that normal force is equal to. Okay, so again, I'll move this off to the side a little bit. There we go, that'll be off to the side. I want to make that smaller there. Oh, that's what I should do. All right, make that a little bit smaller. There we go. Okay, go to a different color here. So now if we go back to this equation, we can say that F net is equal to force normal minus force gravity. We know the net force, 185 newtons. We don't know the normal force, but we do know the force of gravity, which is 725.2 newtons. In order to solve for the normal force, we have to add 725 to 185. So with your calculator, go ahead and do that. I get that the normal force is equal to 910.2 newtons. So now what we have to do is we just quantify this. We say 725.2 newtons is the force of gravity. 910.2 newtons is the normal force. And there we have our diagram that is quantified.